So our lesson for 4.6, which is inverse trigonometric functions, we kind of stopped in the middle of our first page of notes and called that day 1 on the previous lesson. So this is part 2, or day 2. And we're going to talk about composing trig functions together. So think back to some algebra work we've done in the past, where you have the inverse function notation, f to the negative 1 of x, and when you apply a function to its inverse function or vice versa, they basically undo each other and just leave you with the input value that you originally started with. So because of the way we've restricted the domains on the trigonometric functions, they actually have inverse functions that exist, and we can still use those same composition ideas. However, because we have restricted the domain of the inverse of the original sine, cosine, and tangent functions, that gives us restrictions on what we can give for answers to. Sometimes the inverse compositions are really obvious, like they just cancel each other out, which is what a lot of kids think, but it's not always so obvious because there's a whole chart coming up here that tells you a bunch of rules. We'll talk in a minute about how I'll really use this chart. This is the chart I'm referring to. So this is on your notes, and it basically gives you all the different restrictions that we put on inverse sine and sine because of the unit circle and having to restrict the domain so that we had an inverse function to begin with. If you love memorizing stuff, go ahead and memorize this, but I think most of us are going to approach the way that I'm going to approach it, which is just kind of muscle through the question. It's really not that difficult once you remember we have our little inverse unit circle handy. So again, I'm not going to be memorizing any of this because I don't have a brain for that. Alright, so remember, we have this handy. It's already colored up, but if you don't have that handy, you might want to jot the basics of this down. We have quadrants right here, which we're measuring from negative pi over 2 to pi over 2, is where your arc sine and tangent are defined. So arc sine and arc tan, I'll abbreviate that one, I don't want to run out of room. And then from 0 to pi is where we is where we can look for our cosine. So we have to, it gets a little confusing because on the unit circle we're going to be looking at degree measures that give output values for cosine and sine functions, but when we're thinking about arc sine, arc cosine, and arc tangent, I'm trying to find the degree measure that gives me that output, because remember, it's backwards, it's an inverse function, so hang with me. We'll get the hang of this, I promise. All right, I need to get my cursor all set up. All right, I'm back. So I think this is back on our notes here. Yeah, sure is. And we have sine, inverse sine, negative 3/4. So for a lot of students, they just assume that sine and inverse sine undo each other, and then you're going to get the answer of negative 3/4, which maybe. But in order to use that chart that we saw on the other screen, you have to have it memorized. So there are certain cases where it's not as simple as just the inverse sine and sine undoing each other and then canceling out. So what we're going to do is we're going to start on the inside of the composition and figure out at what angle your arc sine would produce a value of negative 3/4. So, or your sine function would produce a value. Let me say that again. At what angle do you get a sine value of negative 3/4? So remember, arc sine, we're only looking in these two quadrants. So because it's a negative value, we're looking down here. And sine giving a ratio of negative 3/4. I know typically we want to look at the unit circle, but this isn't going to be a unit circle type question because the r value is not a 1. So let's fill out our triangle as negative 3/4 like this. So on this particular triangle, which if you want to find the adjacent side, you could with Pythagorean theorem. I'm not going to bother though. I just want to know the ratio for sine on that particular triangle that I drew. Well, sine is negative 3/4. So this is one of those cases where the inverse sine and sine, quote, undid each other, and you just get the value of negative 3/4. Let's look here at number 12. So cosine pi over 2 is the inside of this composition. So if you think about your unit circle, I could just back up the screen, I suppose. Cosine on the unit circle at pi over 2 is 0. So I'm not going to bother drawing anything since I already had a lovely unit circle to work with. So cosine pi over 2 is 0. So what we're really looking at here is arc cosine of 0. So they're saying within the area that arc cosine is defined, at what angle do you get an output for cosine, remember, of 0. So remember, this is where arc cosine is defined. And back here at pi over 2 is where you get a cosine value output of 0. So that was another case where the arc cosine and cosine just appeared to undo each other. So we have to be careful. I promise there's something coming up soon where it's not so obvious. All right. Start on the inside here. Tangent at 3 pi over 2. So remember, tangent formula is y over x, or sine over cosine. It was 3 pi over 2, right? So that's down here. Tangent would be negative 1 over 0, which is undefined. So this guy is undefined. And then the question is, where arctan is defined, or what on the domain that we can use for arctan, when is it going to give you a value that is undefined? So again, back to the unit circle. Remember, arctan is from here to here. Well, the place where it's undefined is going to be... Oh, back up a second, Abruzzo. Sorry, I peeked at my notes and I had something weird written down, so I had to pause. So they're asking me at what angle value would arctangent, provided, undefined as an answer. And if I don't have it with me right now, of course, other than my handwritten notes, but if you think about what the arctangent graph looked like, it didn't have undefined expressions. There wasn't like a vertical asymptote or anything weird like that. So there's actually no solution to this question. That's kind of a weird question. I didn't do a very good job of explaining that, and then I confused myself with my horribly written notes. Okay, so here's a question where it's not going to be as obvious because inverse sine and cosine are not inverse functions of each other, so they're not going to just magically undo each other. So cosine at pi over 6, if you don't remember, you have to go back to your unit circle, but pi over 6, cosine is square root of 3 over 2. So what we're looking at here is this value is really just the square root of 3 over 2. You can't read that, it's 2. So they're asking me now at what angle, for arc sine, remember, so you have to look in the correct quadrants, are we going to get a sine value of 3 over 2, positive 3 over 2. So back to where arc sine is defined. Positive sine for the square root of 3 over 2 is right here, and that would be at pi over 3 radians. Okay, good. I'm trying to see if there's a problem coming up here where we don't just mystically, magically undo each other with like arc cosine and cosine. Yes, there is one coming up. All right, look forward to that. All right, so here, number 15, arc sine 1/2. So I go back to my little unit circle. I think about where arc sine is defined, and I'm looking for an angle that gives an output value for sine at 1/2, positive 1/2. So that'd be right here. So it's pi over 6. So this guy occurs at pi over 6. So then my real question is, what's the cosine at pi over 6? And that is square root of 3 over 2. All right, tangent arc sine negative 1/2. So start on the inside where arc sine is defined. I want to know when I get a sine output of negative 1/2 this time. So sine negative 1/2 would be this guy right here. So that's negative pi over 6. Remember how we defined that. So this is negative pi over 6. So then it says, well, what's your tangent at negative pi over 6? So I think, yeah, there we go. There is a screen somewhere in our notes where we had like a couple of the tangents written out. This isn't one of them, unfortunately. But remember, tangent is y over x, or sine over cosine. So negative 1/2 divided by square root of 3 over 2. One more screen. So negative 1/2 divided by square root of 3 over 2, which means we're going to multiply by the reciprocal, and then we'd have negative 1 over square root of 3, which we'd rationalize to negative square root of 3 over 3. All right. Moving along. 17 is kind of like a trick question. Cosine, arc cosine 2. So they're basically asking you about where arc cosine is defined. When is your cosine value going to come out to 2? But remember, cosine only toggles between -1 and 1, so it's never going to be a 2. So this is undefined, which, like, you can do a no solution thing like that, maybe. Alright, so next question. Arctan negative square root of 3 over 3. So where arctan is defined on our little color-coded circle here, and I want to know where tangent value comes out to negative square root of 3 over 3. I think we just found that when we did a previous question that was at negative pi over 6. That was convenient, wasn't it? So this is really negative pi over 6, and then it says what's the cosine at negative pi over 6, which would be, back to the unit circle, positive square root of 3 over 2. Alright, so far so good. Alright, we're about to see one that comes out weird, so hang tight. I think it's number 20, so we'll look forward to that. Or maybe not. Oh, 20 got changed. My problem number 20 doesn't look like this problem number 20, so what I'm going to do is I'm going to go back and change this number 20 to what my problem 20 looks like, just to really mess with you. Alright, inverse sine cosine pi over 3. Cosine at pi over 3 is 1/2. And then arc sine, so where the arc sine function is defined on that little color-coded guy, so negative pi over 2 to pi over 2, where is it giving me a sine output of 1/2 is sine output of 1/2, boom, right there, which is pi over 6. The angle pi over 6. Okay, so 20, this is an old screen, but I think we updated the worksheet, so I think your worksheet says that this is cosine of 5 pi over 3, because that's what my worksheet says, so let's go with that. Alright, so for a child who doesn't really understand too much about inverse functions for trig functions, they are probably just going to assume that, inverse cosine and cosine cancel each other out like they do in algebra, and the answer is 5 pi over 3. But 5 pi over 3 is, well, it's out of the domain. Remember how we restricted our cosine, and it was just from 0 to pi? Well, 5 pi over 3 is much larger than pi. So this wouldn't be defined at 5 pi over 3 is the problem. So we're going to find the cosine at 5 pi over 3, which, again, I made you suffer through the unit circle quiz, so if you don't have it memorized, off the top of your head, then you have to go find a unit circle. 5 pi over 3, boop, 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 4 pi over 3, so this is 5 pi over 3 over here. And the, what was it? It was cosine, right? The cosine value is 1/2. So this guy is really a 1/2. So now it's asking me where arc cosine is defined, which is between 0 and pi only. When does your cosine function, at what angle does your cosine function produce a 1/2? So back to this page, where cosine is defined, where arc cosine is defined. Cosine giving you a positive 1/2 is right here. So that is at pi over 3. And that is going to be my answer here. So not quite the 5 pi over 3 that a lot of kids think it's going to be. Alright, very good. I'm glad we had an example where it didn't come out so nice. This is like a little mixture of algebra fun with some trig fun. So let's look here. Always start on the inside here. Arc sine producing a -1. So if I think about where arc sine is defined, sorry, positive 1. Hello, I need glasses. So sine comes out to positive 1 up there at the top of the unit circle, right, at pi over 2. So that's pi over 2. And then arc cosine, think about where that's defined, producing a 1/2. That would be at pi over 3. So pi over 2 minus pi over 3, got to get common denominators, right? So this is 3 pi over 6 minus 2 pi over 6, which would be 1 pi over 6. So this whole mess is just pi over 6. So now it says, what's the tangent at pi over 6? So tangent at pi over 6 would be 1/2 divided by square root of 3 over 2, which is this, and then after I rationalize, I end up with square root of 3 over 3. Ugh, that was kind of messy. But, the algebra teacher in me really likes that question because it kind of marries algebra with trig, and that's pretty much what PreCalc is. Alright, so arctan, negative square root of 3. Think about where arctan is defined, here to here. And for the tangent to come out to a negative, we're down in this quadrant. And then square root of 3 over 3 is that one where it would have like had to be rationalized at some point, and that would happen if we took 1/2 and divided by -2 over square root of 3. So this is where our arctan would produce a value of negative square root of 3 over 3, which is negative pi over 3. Now I forgot what the question was. So this, oh, look at that. Okay, this is negative pi over 3. And then it says, what is your sine value at negative pi over 3? And I'm so like brain fried right now, I don't even know. So negative pi over 3, the sine value is negative square root of 3 over 2. So negative square root of 3 over 2. There we go. So I think having that little sheet of where everything's defined handy is a good idea because there's a lot to remember. And like I said, if you really, really love memorizing stuff, here you go. You can figure out some way to memorize these. It's basically talking about the domain and range of your functions and your inverse functions and how they're defined and how they're related to each other. But having that color-coded unit circle, thank you, Mrs. Hoffbauer, is really going to help us kind of muscle through these questions. So that is the next part of our inverse trig. Now there's a whole other page of notes that talks about even more inverse trig. So I'm going to switch to my next file. It says day 2 on inverse functions. It's possible that we got through more of that in one day, but we'll see. Alright, so here, this is on the next worksheet. This slide says it's worksheet 21, which I think it still is 21 for us in PreCalc this year. And this was an old example problem of what we just got done doing. So I'm going to skip that for now, if you don't mind. And I'm going to move down to this guy. This is where it's going to get kind of weird. So we're going to be able to write composition for like any angle. So what if I don't actually give you a specific angle? We're going to be able to figure it out for any angle. And we don't have to worry so much about quadrants anymore because a lot of the questions I give you are going to say like the sine, arc sine, tan, whatever, being a positive value. So when that happens, we're just going to assume that we're like in quadrant 1. Sorry, I got weird hair this morning. All right. So this question says tan of arc sine of angle alpha. So what they did is they drew a triangle and, oh, I'm sorry, that was not an alpha, that was just a regular old A. So they let U, the mystery angle, represent, oh gosh, very clever. Look what they did. Let U represent arc sine, so the inside function here. So if you think about your algebra, how do you undo an arc sine as you apply a sine? So they applied a sine function to both sides here. Sine and arc sine would be canceling each other out algebraically, and you'd end up with the A value is the sine of U, which is right here. So when I look at my triangle, if we're going to assume that we're in quadrant 1 because of everything being positive there, the sine of this mystery angle is represented by A, which is a fraction of A over 1. So opposite leg, or the y, is an A, and then the hypotenuse is a 1. And then we can do a little Pythagorean theorem to figure out this missing leg of this triangle. So remember, Pythagorean theorem is like, I probably shouldn't be using x, but whatever. X squared plus a squared equals 1 squared. So to find a missing leg of a right triangle, basically what you do is you take the square root of your hypotenuse squared, which is 1 squared 1, minus the leg you know squared. So this guy right here is going to be the square root of 1 minus a squared. I don't want to have to do Pythagorean theorem every single time we have these questions, guys, so hopefully you can muscle through that geometry question pretty easy. So now the actual question says, what is the tangent of this mysterious angle? So tangent is a over square root of 1 minus a squared, but no math teacher likes that, so then they would have had you rationalize by hitting the numerator and denominator by this radical, and that's how they came up with that ratio. Lovely, right? Alright, this question is, looks like the same question to me, is it? Yep, so I'm going to move on. Alright, these are, you know what, these are actually in your notes for once. So it says arc cosine x, x is positive, blah, blah, blah. We're going to assume that we're in the first quadrant. So, spoiler alert, I think pretty much all these are in the first quadrant. Actually, I think literally all of them are in the first quadrant. So we have some mystery angle here, you know, whatever you want to call it. If you want to go back and call it U, you can. But the arc cosine is coming out to x, which means that the cosine of this mystery angle is x over 1. You have to think about applying the cosine. So the cosine, remember, is adjacent, or x, it's convenient, over hypotenuse, or r, which is 1. And then doing a little Pythagorean theorem, this leg would end up being the square root of 1 squared minus x squared. I don't even know if I need that. Well, apparently I do, because I want the sine ratio for this angle. So the sine of this mysterious angle is the ratio opposite, or y, over hypotenuse. So basically, the sine ratio for that angle comes out to square root of 1 minus x squared. Alright. Arc sine coming out to an x, positive, so we're back in the first quadrant again. Drawing a mysterious triangle with this mystery angle of u. So arc sine of x means that the sine of my angle is the ratio x, or x over 1. So using my sine formula, I can fill out that part of the triangle, and then using Pythagorean theorem, I end up with 1 squared minus x squared. Very similar looking setups here, but everything has a little bit of a change to the previous problem, so you have to be careful. So cotangent, old formula is x over y, new formula is, old formula is adjacent over opposite, and then the newer formula is x over y, but x meaning this adjacent leg, y meaning this vertical leg. So the cotangent of my mystery angle here is the square root of 1 minus x squared over x. Thank goodness we don't have to rationalize. We are done with that question. And I'm kind of looking ahead at my notes, and these really don't really get any more difficult than this, so I'm just going to do a couple more of these, and I'm going to call it a day on this lesson. Alright, so arc cosine x, whoops, that's supposed to be a quadrant mark. We're in the first quadrant here. Arc cosine x, meaning that the cosine of our mystery angle is x, or x over 1. So cosine being x over 1 sets up like that. My missing leg here would be square root of 1 squared minus x squared. And then they want the sine ratio for this angle. So sine of this mystery angle is square root of 1 minus x squared over 1, which of course no one would write that. We would just write square root of 1 minus x squared. So, one more and then we'll call it a day. Inverse sine of x. So, that means the sine of our mystery angle is x over 1. And then a little Pythagorean theorem, we get 1 squared minus x squared. And if I'm setting up the tangent ratio, the tangent of angle u is x over square root of 1 minus x squared, which no math teacher would be happy with that answer. They're going to expect you to rationalize. Let's use a different color at least. So multiplying numerator and denominator by square root of 1 minus x squared gives us a ratio of x times the square root of 1 minus x squared over 1 minus x squared. Now, please resist the urge to cancel anything. Nothing in that fraction cancels. That's actually your complete ratio. All right, call it a day.